Today we're talking about JCache. I slightly changed the title. It originally was the Hazelcast JCache way, but I made these slides more general. We have a short introduction to Hazelcast to see to understand the examples, but the main talk is JCache. Why we want to have a caching standard, what is nice about JCache, where we're going to, and some things like that. So let's see. First of all, one thing is very important. This talk is very serious, so whenever you have the feeling you have to laugh, please stay quiet. So I think a lot of people know that. We're just jumping over. Nobody needs it. So who I am, I'm Chris. I'm working for Hazelcast, obviously. I'm a Apache committer. I'm a committer for direct memory, which is also a caching solution. I worked in the gaming industry. I worked in travel management. Most of the time I'm doing funky stuff like performance optimization and GC optimization, and the rest is more like fairy tales. I prefer to tell about me as the new Chuck Norris. Some do not really agree on that. So what do? Well, we want to cache, right? So who's the best one? Well, a squirrel. Why do we want to cache? We see some numbers and we see that different kinds of memory areas have different access times. So obviously the fastest one is the L1 cache inside the CPU, and what is pretty bad is 150 milliseconds if you send a package from California to Netherlands and to California back. So what most people do is they go for something like SSD cache, writing down to disk. SSD is obviously fast. It's only 0.15 milliseconds, but the idea is keeping everything in memory, so 100 nanoseconds, which is an obviously pretty good number. There were some solutions in the past. The first one, and that's why I asked earlier, is you do your own implementation. I guess the 3-4 people that did their own caching solution know what I'm talking about. It's not a nice thing, it's not an easy thing. You have to think about a lot of things. Most of the time, unobvious stuff like eviction, TTL, those kind of things that just come to your mind when you first encounter the need for it. But at that point, you already, well, get to the point where you try to, well, where you actually implemented the first steps. The other option that more of the people here used is have some proprietary cache. Most of the people were JCache. There are a couple of others. We have Coherence, we have Hazelcast, we have Terracotta, which has another cache next to JCache. There is, I don't know, plenty of others. The third option, and that is the important one we're talking about today, is JCache. JCache is the new Java caching standard. It's JSR 107. I'm one of the expert group members, and we really try to make the JCache specification not what JPA is. JPA, even in version 2 point something, sorry for the guy before that had the talk before me, is still pretty bad to use without any kind of vendor extension. You still have problems with many-to-many relations. You still have a couple of other problems with JPA API, and we don't want to do that with JCache. So what we do is, even though we go for our own competition, or own competitors, we want to make it as usable as possible for the user, and with as many features as possible. So why do you want to do that? Obviously, in the past, everyone did his own stuff or used some proprietary cache solution. When you changed from one company to another, there was a high chance you had no idea what is going on, and you had to work into the used caching solution, no matter if it was a custom written one or if it was a bought one. And why you want to have a standard? Obviously, the opposite. You want to know, I can move on in the company. I can move from one project to another in the same company, And whenever I see caching, I know what the people are talking about. I know the API. It's like Java util map. Whenever you move from one Java project to another, you know what a map is. And the good thing is we don't want any kind of proprietary solution anymore. Sounds like a good time to be, right? It's time to be happy. So the thing is, it took quite a long time. The JSR started actually in 2001. And 2001 is back 13, almost 14 years. It was started by Sun Microsystems and IBM. As far as the people remember, nobody can really tell you who started it. This is the interesting thing. This is from the Wayback Machine. I guess this is the best information you can get about the original status. And it was almost like that for a long time before in 2012, Brian Oliver and Greg Luck took over the JSR and said, okay, we're waiting so long for it, now something has to happen. And in March 2014, we got the final release and people actually started to really implement the final specification. So JCache in 5 facts. It's JSR 107. The official name is Java Temporary Caching API. Everybody calls it JCache. Stay with it. It was actually the longest running JSR ever. That is finished by now. So there are a couple of JSR that are still open. Maybe someone will make a longer running one. What is very important to me is it targets Java 6. So it's not Java 7, not Java 8. A lot of people still have applications, have the need for Java 6. We know that from our own customers. We have a lot of banking customers. They will be by Java 6 maybe, Java 7 maybe by 2020 or something, maybe 2050. It is like map, but it's better because it's meant for caching. We will see some methods which look like the map interface, but there are slightly differences that make it pretty nice. And another very important thing, I already told it, it's vendor agnostic. So I'm working for Hazelcast, but whoever is going to go for JCache, he can use EHCache, he can use coherence, he can just switch it underneath and it still works. So as I said, I'm working for Hazelcast. So there are different ones. Obviously, the first one for me, it's us. We have 2 members in the expert group, me and Greg Luck. There's EHCache, which most of the people already know. There's InfiniSpan. Oh, I missed InfiniSpan in the beginning, right? So Red Hat and coherence. There are a couple of more. I know that GridGain is currently working on implementing JCache. There is what else? Encache, which is a .NET-based solution, but they have a Java client which is going to implement JCache. But those are the ones that currently passing the TCK and that are certified to call themselves JCache. Okay, since I'm working for Hazelcast, let's quickly have a run through our own system. I'm a bit reckless in sneaking it in. But to go through the examples, I guess it's good to have at least slightly overview. Okay, so let's Google it. What is Hazelcast? That is Hazelcast. Well, obviously it's not. Hazelcast is like, I love to call it picking the diamonds. We have the Java concurrency and Java collection API implemented in a transparent distributed manner. That means you have a distribution system that still looks like Java code. It doesn't have any weird vendor-specific API. We have a distributed executor service on top of it and all those nice little things. Who haven't been yet at the booth, there's a booth over there. And so Hazelcast is a data partitioning system. So we're sharing data. You can call it sharding data, but never say that to a database admin. He will kill you. Especially if it's a relational database. We distribute data. It's almost like partitioning. If you have a cluster and you put in something, we see which node will be the owner of a special key, and then we send the data over there. And I guess you get the idea of distribution. We parallelize processing. As I said, we have executor service, we have MapReduce, everything running in memory, and we have some lightweight pub/sub implementation topic, not as heavyweight as JMS, but for most of the operations from our customers, this is amazingly good. It's low latency, and obviously, as I said, it's not JMS. Oh yeah, and for sure we do caching. Fault tolerance by default, and I guess that is actually the last slide about Hazelcast. So we keep backups. Whenever a node goes down, we can restore the data from the backups. Nothing very special. If anybody wants to read that, I give you a second. Otherwise, let's go on. Oh, it's not the last slide. Sorry. So Hazelcast combines all the good things that I already told you, like collection API, concurrency API, the executor service kind of things, and it's still, our biggest vision is we want to make it as simple as possible for the users. And that is actually the last slide. It's all about scale out, and it's not scale up. So there are some vendors, we don't want to name them, that try to sell you bigger databases all the time. We try to say, just get some more smaller hardware, scale out, parallelize the processing. And that pretty much fits pretty well into the distributed caching, or in the JCache distribution, because it means with cheap hardware, you can get a big heap, you can store a lot of data in the cache, and you still have the option or the advantage not to go down to a slow database or to slow network calls or whatever. Okay, and that is also the almost last slide of the slide deck. Let's jump into the code. Let's see if we can make that happen. Nope. Whatever. Just do it. Okay, this is actually the wrong one. Let's create a new project, new module. Come on, this one. We want to have a Maven module. We call it Hazelcast JCache. And since I'm a very, very lazy programmer, I just copy the dependencies. We have two dependencies. First of all, we have the JCache API. This is the actual set of interfaces that is going to be used for JCache. It contains the provider SPI, so for whoever wants to implement a JCache provider, he has to implement it against the JCache API. And the other one is the Hazelcast implementation. Since we only have one JCache implementation, this will be picked up automatically whenever you ask JCache for a caching provider. So let's do that. Where's my new module? Is it that? Oh, there you go. So let's create an amazingly important package, Hazelcast JCache. And then let's do a first look at how JCache actually works. Let's call it main. So let's make it. I think that is readable, right? Okay, perfect. So as I said, the first step is JCache has to figure out what are the available providers in the class path. We go now for the simple version because there's only Hazelcast. If you would have Hazelcast and EHCache, you would have to decide manually which one you want to have by supplying the JCache class name. So the first thing is we want to have the caching provider, which is retrieved by asking JCache for, okay, please give me the first caching provider you find in the class path. Okay, so far so good, looks pretty easy. Then there is a caching manager, cache manager. And a cache manager is, how to say that? Multiple caches are coordinated by the same cache manager. A cache manager can have a namespace, it can have a special class loader. It is some kind of a management mechanism. If you, for example, have multiple applications running in the same servlet container and every web application should have its own caching manager, then the servlet container would provide you with a caching manager. This is somehow named after the running application or something. And then we need mutable configuration, because JCache is configured at runtime. There's no way to pre-configure it in the specification, at least. I could say Hazelcast can do that, but that is out of scope for you. So the good thing about JCache actually is all of the JCache API is completely type safe. It's not only that we have the generics, but we also can say new mutable configuration and set types. And we put in the same types here, class, string class. And if we do that, it means we get runtime checks. We get checks on put and we get checks on get of values. So we can be sure that there's nothing in the cache we don't want to have. This is one of the big differences from a lot of other caching solutions which have the generics, but whenever you remove the generics and use raw types, you can put in whatever you want. If you use set types, it's not possible. Otherwise, you can't pass the TCK. And then we're almost like done. We have a Java Xcache cache, and this is integer string again, string. And because we just have one caching manager and we have a simple cache, we say, okay, call it Devnexus and pass in the configuration. For a local cache, this is pretty easy. It creates a cache in your local node, and that's it. For a distributed system, this is a bit more complex. I guess I can tell you how it works in Hazelcast, but I'm pretty sure it works in all the other distributed caches pretty much the similar way. You send over the cache construction to some node that owns this cache and takes care of all the mutations and registrations of different nodes. And then eventually it comes back and says, OK, I created it, and now we're good to go. OK, so far so good. Let's have a quick look at the cache interface. We see it's an iterable, and it is a closable. And if we look at the simple methods, well, we have a get, which is almost like map. Let's make it a bit bigger. We have get all. We have contains key. And here's the first big difference. We have put, but a put doesn't return the old value because it doesn't make sense for a cache. This is actually a pretty good thing for distributed cache, because it means you don't have to send over the old value back over the wire to the caller. By the way, whenever there's a question, just interrupt me. But you have get and put. So if there's a likely chance of you want to use this old value, just explicitly ask for it.
I'm familiar with Hazelcast with eviction. Where does the eviction policy map into JCache?
JCache, let's put that in the next example. It wasn't planned, but we can do that. To give a short answer to that, JCache has its own eviction policies. we will see that in a bit. Okay, so I guess now we can say something like put 1 and we're in ballroom B, and who can guess what happens? I guess everybody, if we call that and execute it. We will put a value B in the cache. The interesting thing though is when I start it up now, we see a lot of messages coming up. This is automatically done because I requested Hazelcast to be the JCache implementation. So I start up automatically a Hazelcast node because I don't have a remote cluster to run against. And I see I have one node over here, and I'm doing something very important. Size out, cache, get 1. And I leave the old node running because I already have a cluster and I want to show that the second node, because it's a distributed cache, can actually request the value. So I start up a second node. The first one is still running. They find each other automatically, I hope so. I haven't tried it today with the Wi-Fi network, but it should be. There you go. And well, it returns ballroom B. Well, very, very expected, I hope. So let's shut that down. So you asked about expiry policies. Let's go into that. So expiry policies, I hope I'm not wrong, can be either set over here. So you can either set a global expiry policy. Let's do that first. Access. Sorry? We still have that. Well, let's make this the next one. I like interactive discussions. So we have last access, I guess. Last access. No, it's not last access. Let's see what it looks like. Eviction policy, factory. Expiration. Oh, where are you? It's a good and a bad thing to just create some examples out of the box. It is accessed expiry policy that way. And you say factory of. No, you factory of duration, right? Duration. Let's move that down. Duration. And you have a set of prefix durations like 1 hour, 10 minutes kind of things. But you can also say, okay, I want to have a duration of 10 seconds. That's how it works. And it still doesn't work because, oh, it has the wrong Java FX. What? Are you kidding me? Sure, let's take that one. And then it's not seconds, it's... Oh, this one doesn't have the seconds anymore. Okay, make it 1 minute. We're flexible on that. What is wrong here? Oh, good point. And now we set it a global expiration policy inside of the cache. That means every value I put in will be expired by 1 minute automatically. So let's see, we're not going to have 1 minute.
Expiry on individual items as well.
Sorry?
Entity listener. Entity listener will probably give you individual entity eviction, not the whole cache.
Enter listener will give you... I'm not sure, can you come again?
Well, my question was, can you set an expiry, a separate expiry?
Yeah, exactly. That's the reason why I said this is a global one. So this is legal, or this is real or true for all values you put in, beside the fact, and let's come to that, is that not in the spec? It is. It should be. Okay, I have to admit it's not in the spec. It's definitely an extension from us. So you can do it in Hazelcast, but it seems like you can't do it in the specification. I'm sorry. Worked too much with the Hazelcast implementations in the last time. So whenever you put in something, ballroom B, then it will expire in 1 minute. And Hazelcast implements it as a lazy expiration. That means it will not automatically be removed from the memory, but whenever you access the value, or whenever you need some free space in the cache or in the memory, we expire some of the old values that are already expired or whatever. To show that it actually works with us, this is our extension. So if you do that, you have to do it differently, right? Make it the spec way. You could just cast it, but let's do it the way it is meant to be. Cache, unwrap, iCache class. And then you can set expire. Come on.
You're still referencing cache, not iCache.
Oh, yeah, not a good day for me, I see. Created expiry policy, factory off. So for the iCache thing, I don't make this complete. For the iCache, you can put in a special expiration policies for single keys. One thing, though, that is very interesting about the expiration system that is internal in JCache is that you have different, that if you implement your own expiration policy or expiry policy, you have a duration for creation, you can have a creation for access, and you can have a different duration for updating. So depending on what happens to your values, you can set different values for the next expiration date or next expiration timeout. So this might be very useful if you have frequently updated values and you want to make sure that those are staying longer in the cache than things that are not frequently updated. Let's see. You asked about entry listeners. Okay, let's do that next. Remove that again. We don't want to add this anymore. Clean up a bit. Okay, so entry listeners. I guess everybody is familiar with the idea of listeners and what entry listeners are. Any question on that? No, okay. So let's say public static class my listener. And now I have to look that I get the right one. Is cache entry listener. And let's go for the interface first. So the interface itself is nothing more than a marker. So any version or any special listener will be one of the subclasses or sub-interfaces from entry listener. Wrong key set. There you go. So I can't make this bigger. That's not nice. So let's say we have a cache entry created listener. So it extends cache entry listener, so it marks itself as an entry listener, but it only has one method, which is onCreated. There are different other things. There is a cache entry updated listener, there's a cache entry removed listener, and I think I missed one, expired, I guess. Expired is the fourth one. So this is very different from a lot of other typical entry listener or listener systems. To be honest, I'm not 100% sure why they came up with that idea. Maybe because of lambdas we're already ahead of the time, or I don't know. So let's say we want to have a created listener, so we change that to created. And we have integer and string. Up. And we see we have a created method. And again, we do something very important. We just throw out all the events. So one thing is important here. It might not be that you get one event, but the underlying implementation might decide to batch up multiple events for a single call to the event listener. This is, for example, if you have a put all or you do put all, it might be that the underlying implementation decides if I did all the puts, I can even give you all the events at one time without sending them over the wire one by one. So those are also set in the configuration. What a wonder. Add cache entry listener and new my listener, which won't work because public statics integer string. What are you talking about? Oh, right. You have to create a cache entry listener configuration. Listener. What is a subclass? Also mutable? Sure. It's mutable. I not totally agree with everything in the spec, as you might recognize. Come on. So it's again mutable cache entry listener config, and then you set the factory, and the factory is factory of instance. Not factory? Factory builder array. Factory of, there you go. New my listener. And it's still not happy. Cannot resolve? Factory of T. Sure you can. Why you don't want that? Oh, yeah. The other kind of weird thing I don't really get. It's still not happy. Oh, this is for sure. The other one is happy now. Look at the right thing. Cache. Listener configuration. Now it's happy. So, as you see, all the listeners need to be serializable for an obvious reason. Right? And then we just put in something to see that it actually works. Again, some amazing business logic. I and value. And something is unhappy again because cannot resolve constructor. Sure. Move it over here. I can't say I totally unagree with it because, as I said, my boss might don't like it. But I don't get it. Let me make it smaller. Might be better. So that is meant to be that way. cache entry listener config factory, cache entry listener, listener factory. Oh, the filter thing. No. So the configuration for entry listeners is not as easy as it seems like. So we have the factory, and next thing was we don't have a filter. We want to have synchronous events and whatever that was. Oh, we want to see the old value, and we want to have synchronous events. Very obvious. And now if we started, after we made everything happy, we see that we start a cluster again. And we see 5 events coming up, key 0, 1, 2, 3, 4. As I said, I'm not very happy with this configuration style. And obviously, I haven't done it a lot. I was more in the implementation side for Hazelcast, and we did a lot of things way more easier, I guess. I hope so, at least. OK. Any other things you might want to see? Annotations. Yes, you mean the cacheable annotation. I cannot directly show it to you because the cacheable annotation is meant to be implemented by containers like Spring. And that would mean I have to set up a whole Spring application now, and I'm sorry. But yeah, it's part of the specification.
No, I think the reason why I was mentioning is there is, in annotation, there is something about time to live.
In the annotation, there's something about time to live. Yeah, but this is the cacheable annotation. So the annotations are meant to be implemented by containers like Spring and whatever's out there. So they exist, but they're not usable in the normal specification. They are marked as optional, and it's free for the provider to implement it or not, for example. I think there was somewhere else, no? OK. Yeah.
Do you still support that if I don't want to go to the JCache way, make it a very abstract way, the Hazelcast instance, is it still supported?
The Hazelcast instance.
Yeah, but let's say that if I don't go with that.
So you mean you create your own Hazelcast instance up? Yeah, you can do that. This is more like a Hazelcast specific question, but you can do a Hazelcast caching provider and either reference it by its instance name, you can reference it by Hazelcast XML location, or you can go with Hazelcast server caching provider and create a caching provider with a passed-in Hazelcast instance if it is on the server side, or there's Hazelcast client caching provider, which can be used for Hazelcast client instances, if that answers your question.
Before that, we use the Hazelcast instance. If it will give you an instance of the Hazelcast, you can go and start.
You mean something like Hazelcast, your Hazelcast instance, and you can pass that in here. And it will still, not caching manager, caching provider should it. So it should be, over here. Instead of asking the JCache API, you can still create it on your own. But it really depends if you want to do that, I guess. But we can discuss that maybe after the talk. So anything else people want to see about JCache? OK, so let's see what else do we have. We have events, we have configuration. I think you talked about, is it possible to see that? The annotations over here, right? Yeah. As I said, the annotation feature is mostly meant for Spring. It's also mentioned in the specification that those are meant for special containers like Spring, and someone else is named. I can't remember it. So let's see what else do we have. Let's remove the entry listener again.
Can you show a write-through cache?
Yeah, exactly. That was my next idea. JCache supports write-through, read-through, which means you can have an underlying database, and you can just grab a value or grab a value by key, and if it's not yet in the cache, it will go to the underlying database, read it into the memory, store it, and returns it back to you, and for the next access. This is even faster. So I guess we can show this by creating a nice small application, which might be better than just having this small thing here. So we have, again, our caching provider. Caching provider. Caching provider, and we say we want to have a cache manager. And to make it a bit more nice, we do a very, very important database access. We have a user DAO. Everybody knows the DAO pattern and knows how amazingly important it is. I'll make it bigger again. And for simplicity, we're just going to implement one method. We need to have the user object. We have a user ID. Sounds good. And what else? A username. Let's create the standard stuff. Getters and setters. I should work more on my MacBook, I guess. And we want to have a toString method to have something nice to show, and that should be fine. So let's create a very, very simulated and made-up use case. We have our URDAO impl. That way, which implements user DAO and has the one method. Let's create a final map integer. A small map which contains our users. User. And let's put in some users. Is there someone who wants himself in the system? Obviously not. So let's put in user one, set user ID. Set user ID, why does he always want to go for a get? It's always funny if you work a lot on normal desktop computers, which are not Macs. You have no idea how to use the keyboard. Let's make, we call him Peter. I like Peter. And then we do something like users get ID. But since we want to simulate a slow database, let's do something like spread sleep, 2 seconds. And then return it. So I guess everybody understands why that simulates a slow database, right? So we want to have our first of all, we have our user DAO, which currently is our normal user interface. And if I call that 5 times, get 1. We get some value, but, well, obviously, it is a slow solution. The nice thing, though, is since the user DAO is an interface, we can just say, OK, let's create a cache for that. So we have a cache user DAO impl. And the important thing here is we first have our JCache, which is integer user cache, and private final. And we put in the other user DAO that we want to wrap, so we have a wrapped. And let's create a constructor for that. What we then do is, well, I guess everybody knows what's coming up. So you get the key from the cache and hope it's there. And equals 0, right, and equals null. Return user. Otherwise, we have to look it up. Wrapped user DAO. And so this is the part you still have to do if you don't use anything like Spring, which has an integration directly for an underlying caching provider. There in JE, with Java 8, JE8, there will be a direct integration into JCache, since it will be part of the spec. So you can expect that if you work in the JE or in the Spring environment, with the next version, you will have automatic JCache support, which helps you a lot and provides you from writing this kind of boilerplate code. And now we have our cache here. We created integer user. Sure, we have create mutable configuration first. Let's remove that. So you don't need to have this runtime checks. They might be nice depending on your use case, but you probably don't need them. I guess this is almost like depending on how much do you trust the other developers to do the right thing or not. And then we create our cache user DAO. We put in the cache and we put in the rep one. And if we start up that one, we remember the first run was 2 seconds every time. Obviously, it will obviously it will throw an exception for sure, because we use Hazelcast and Hazelcast tries to serialize the object. That's definitely not my day. Oh, let's stop the first one. There you go. So the first try was still 2 seconds because we had to go to the underlying database, but we immediately stored it in memory. Okay, so that was the first one. And the real question now was to have it transparent to the user, right? So we want to have, instead of putting it, wrapping it ourselves, we want to have the underlying DAO as a read-through operation. So read-through means we have public static class my cache reader thing, cache loader. That's the name. And I guess we end up again with some weird public static. Oh. We ended up again with some weird configuration magic, as far as I remember. And we put in our DAO here, private file, user DAO. And we say whenever something comes up, just pass that through. And what we now do is, instead of using that one, and this, we just say cache, and let's see how we have to configure that. Set read through to true, and cache loader factory. And again, this thing needs to be serializable. This one. Factory builder, factory off, new cache loader. There you go. Okay, that means we tell JCache to immediately read through whenever it doesn't know about a value. You can activate or deactivate it. So if you set this to false, which I guess is the default configuration, you would have to tell JCache, okay, please go to the database and load the data into memory. You can do this eagerly. You can do this while runtime somewhere. But you asked for a read through, so let's do it automatically. And then you set up the cache loader factory, which again will create our own cache loader. And if we run this again, we hopefully see the same result, but without the configuration need, or without the boilerplate, at least with less boilerplate than the time before. So we have about 20 minutes left. Anything else or some questions? Nothing?
What kind of mechanism do you use for discovery? I know you have
In Hazelcast itself, you mean? Yeah. So we're coming to the Hazelcast questions. By default, we use multicast. That's the reason why it is nice for demonstrations. You can just fire up multiple nodes. But we also have AWS and TCP IP. So if you have well-known IP addresses, you can put them in. What also works is having 2 or 3 known IP addresses. And whenever someone connects to that, we share the topology completely.
I'm not sure if it's really even theoretically possible, but can we attach hook to the database itself? So if someone else is updating the database and I'm consuming the same database, let's say, or a table, so that if there is a corresponding cache object living in my JVM, it should also get a...
Okay, so you mean, for example, you have 2 applications mutating the database and you want to automatically update the in-cache value. This is not part of the spec, and Hazelcast also doesn't implement it. It doesn't implement that. I think there is something for Oracle coherence from Oracle. I know there's a Swedish company called Speedment. They also have something like a trigger solution, which hooks into the database, and whenever something is changed, they can change it. At least for Hazelcast, I know that it works. I'm not sure how it will work with Terracotta or something else.
But the basic idea of using this distributed cache will be the application should use directly the cache, not directly the database, right? Suppose if I am running a Hazelcast cluster, right, and I have two applications.
If you run a Hazelcast cluster,
then the Hazelcast instance running, right? And then I two applications should interact through the Hazelcast, but not directly to the database, right?
I'm not sure I get your point.
My question was around two separate JVMs not consuming the same cache. It's just two separate applications consuming the same database.
Yes, so right, the point you make is you have two independent applications mutating the same database, and if those can be somehow synchronized. Not out of the box, at least. There are solutions, as I said, at least the two I know, but I'm not sure if there are other solutions. And I mean, this is a pretty hard thing, though, because you have to have knowledge of the underlying database. It's for relational databases, you might have triggers. For NoSQL, I mean, you can also read from NoSQL databases underneath, and you might not have the option, or you might have listeners. I think it's very hard to have a standard implementation for that, but it's obviously possible. So, as I said, there are solutions doing that.
Have you benchmarked how many nodes you can scale per example?
It's funny that always Hazelcast questions coming up. We try Hazelcast in AWS ourselves. So every time we create a new version, or we going to a release for release candidate, or for snapshot versions, we have our own tool which starts up multiple machines and tries multiple training sessions, simulating load, simulating runtime environments. And I guess the biggest cluster we ourselves ran was 100 nodes and up to 1,000 clients. But I know that the biggest customer cluster so far is 620 nodes at least. So we definitely have to keep up with the customers at some point, because it's not possible that they run the biggest clusters. I think you had a question? No? Okay. Samuel? Huh?
I think I have one more Hazelcast question, I think.
Yeah, sure.
So you talked about the nodes a few minutes ago. I think I got the idea that you can actually synchronize the offset nodes with the same cache object.
Yeah, so the main point is that you have a distributed cache. A distributed cache means whenever something is in the same cluster, the cache manager is actually the namespace, the reference point on how to differentiate between the different cache managers. And whenever you request the same cache manager, no matter if it is the default one or someone you named or you gave a special version or special URI to, you end up with the same cachings and the same data. What is important, though, if you create the same cache multiple times, and that is where Hazelcast is a bit different. So normally you use this create cache, but for Hazelcast you can pre-configure those caches inside of the XML configuration, and then you just use get cache. So if you just use the API and you would have a distributed cluster, you would try to create it with create cache, and if that fails, you have to use cache manager get cache with the same name and make sure that the configuration matches. As I said, if you use Hazelcast, you can pre-configure that, and then you just use get cache, and if it's not existing, Hazelcast will automatically create it for you. Otherwise, it will just return you the instance that it already exists. So you.
The cache is one server. That's it propagating all the
It's not running, not living in one server. That's why I had this short introduction to Hazelcast. So we partition the data. That means if you have 3 nodes running, we partition the data of all 3 nodes. If that makes sense. Anything else? Yeah.
So if you have a customer and multiple nodes for the cache, accessing the same cache.
Yeah.
And if you insert from one node, is that data replicated?
It's not replicated. So we partition the data. That means we're serializing the key, we're applying some consistent hashing, and depending on the outcome of the consistent hash, we nominate one of the members of the cluster to be the owner of the data. That means it will be sent to that node, and then every time you request that key, it will be requested from that node or from some backup, depending on your configuration.
So is that a failover scenario?
Yeah, it is. So, yeah, by default, we keep one backup. You can set the backups to everything between 0 and 8 in any configuration of synchronous and asynchronous backups. So you can have 2 synchronous ones and 1 asynchronous, or 1 synchronous and 2 asynchronous ones. And whenever a node fails down, we have a backup. We just reactivate the backup and migrate the data to be equally distributed again. Someone else? Okay, and I guess, oops. Oh, well, if you're quick, we have an Oculus Rift. It was not the slide I wanted to show, but obviously we have one. And otherwise, my girlfriend wrote me. Perfect timing. Well, thank you. It was not my best talk today, definitely.